In the last video, we spoke about one possible way of implementing the approval system. Let's now talk about why this is a very poor approach. So we're going to take a look at a diagram. All right, so inside of our imaginary approve request function right here, I want you to make a little assumption with me. I want to assume that the logic that we placed inside this for loop right here, like this loop to check to see if the person who is sending the transaction is inside of that approver's array, and if they are, we flip this Boolean flag over to true. Let's assume that that entire operation right there costs 10,000 gas. So this if statement right here costs 10,000 gas. So in total, this for loop costs 10,000 gas for every person who has donated to our contract or to our campaign. And then in a very similar fashion, this require statement right here, maybe this costs 5,000 gas to execute. So the entire for loop down here costs 5,000 gas for every person who has already voted on this particular request. With that in mind, let's do a little math on exactly how our gas costs are going to scale. All right, so here we go. For one person or for one contributor, just to check to see if they are a member of our campaign, maybe that costs 10,000 gas. We have an additional 5,000 to see if that person has voted on that particular request. So in total, for one contributor, one person, doing this entire function costs 15,000 gas. All right, that seems reasonable. We've spoken about gas and we've said that it's the cost that it takes to execute some lines of code inside of our contract. And we haven't spoken that much about how gas really costs, but let's just imagine, sure, 15,000 gas for one person. So let's now take that other requirement we had over our voting system. Remember, the other requirement was that we should have a voting system that allows for many thousands of contributors inside a single campaign. So what happens to our gas costs when we start to imagine a campaign with thousands of people? How do our gas prices increase? Let's imagine that we have 10,000 contributors now. So if we have 10,000 contributors, we have to run that first for loop 10,000 times. And that if statement that we were executing cost 10,000 gas. And then for that second check, we are now doing that require statement that costs 5,000 gas, potentially 10,000 times. In total, with 10,000 contributors inside of our contract, we could now be spending 100 million gas. So as every single person signs up or donates to our campaign, we are incrementally increasing the cost of our approve request function by 15,000 gas every time. So as soon as we start to get a very popular campaign, maybe with 10,000 people, we might be having to spend a tremendous amount of money in order to call that approve request function. So that is why this is a very poor approach. That is why using an array for our addresses out here and an array for our addresses inside of a given request is a very poor approach. This is a case where we are designing a contract that has an array that grows unboundedly. So we have written our contract in such a way where we have to assume that this array of addresses right here is always going to grow without bound. And we don't have any way of restricting the size of the array. And in fact, for the purposes of our contract, we probably don't want to restrict it, right? In theory, we want to allow as many people to donate to our campaign as possible. So it would be really bad for us to start to add some logic to somehow cap the number of people who can contribute, and thus cap the number of addresses that we store. This is a problem that is not only related to this voting system that we've put together, but to any type of a use of an array data structure in a contract. If you are storing data inside of an array, and then you have some logic that eventually loops over that array, you have to be 100% sure that your contract is never going to end up with that array growing tremendously. Because if it does, and then you start to iterate over it, you might be signing yourself up to pay some tremendous amount of money in gas. So in closing here, the entire idea behind our voting system as it stands right now is that it is way too expensive because we have these array data structures that we have to loop through to see if someone has voted before and to see if they have even donated to our contract. And because we are looping through that contract, we have to spend a tremendous amount of money as more people are introduced. Anytime you start working on your own personal contract, I'm going to very, very much encourage you to avoid working with arrays wherever possible. So of course, this kind of comes full circle now, where I had said previously that this approvers array of addresses right here was something that was a poor way of addressing our voting system. And so we are going to update this data structure right here to use a slightly different data structure that doesn't require us to iterate through every record inside there to say, see if someone has contributed already, or see if someone has donated to our approved a given request already. All right, so hopefully that's a little bit more clear, and hopefully that makes it a little bit more obvious why our current design of our approvers array and why the current design or the design of the voting system I just laid out is not a good approach. In the end, it just costs way too much gas, way too much money, and it might eventually cause our contract to not function anymore. So let's now take a quick pause. We're going to talk about how we can address this and some other data structure that we can possibly use to make sure that we are still able to handle many people inside of our contract, but also implement the requirement of only allowing one vote per person on a given request. So we'll talk about that alternate design in the next video.